Hello, hello. Can you hear me? Hello. Okay, great. Welcome, everybody. Welcome, welcome. Please type your name. Where are you dialing from? From which country? Actually, I'm dialing from Indonesia this evening. All right. I hope the weather has been good. Hi, David from New Airlines. Good morning. Monteza, UK. I think good afternoon. Arsalan, Saudi Arabia. Probably good afternoon also. Yulong, okay, good evening, good evening. Singapore, I'll be back in Singapore tomorrow. Ajar from Malaysia, neighbor. Good evening, Daisy, Jakarta. Daisy, I think I know. I think you joined. I think last week also, right? Okay. Hassan also joined last week also. Hi, Hassan. Welcome back to Nigeria. Who is joining for the first time? Chung Wo from Vietnam. Hello, Vietnam. Oh, Zebo, first time. Welcome, welcome, welcome. All right. Anybody else? Right. I think we have a smaller audience today, right? Morteza, first time. All right. Welcome, welcome. Good to see you here. All right. Okay. Okay. Let me know. Sridhar from India. Hello. Kalpesh. Sorry. India. Kamran. Hello, Kamran. All right. Okay. Welcome, everybody. I would love to say hi to all of you. If you type, I will try to say hi. But let's get started, right? So, let me. Okay, I'm going to turn off my video now, right? Enough of my face, right? I'm going to bring up the screen better, right? Can you see the screen better now? I think it should be full screen on your whatever device you're doing, right? Full screen, yeah. All right. Let me do a quick poll, which is who has used Aspen File System Analyzer? Before. Sorry, I should have typed this before, but I was quite really busy this. Right, so let me post this to the chat. Right. Yeah, just give some feedback, and here you go. The poll should be on the chat. All right. While you're filling up the questions, yes or no, whether you have used the Aspen Flare System Analyzer, right? I think my goal today is to give a really quick tips for those who has not used to really get started quickly with Aspen Flare System Analyzer, right? So I think Aspen Flare System Analyzer, okay, let me just flip this, right? Okay. I'm going to skip the introductions of my introduction. I think most of you are already few times here, right? But anyway, short introductions. Currently, I'm working with Aspen Tech, right? As a solution consultant. I had the solution consultant for engineering in Southeast Asia and covering Southeast Asia and Australia, right? So that's short introduction. All right. You should see maybe the menu. I see my menu today got a little bit changed. The orientation. I think the button not no longer on the top is actually on the right for me. I'm not sure for the audience, right? But there is a button for chat and Q&A. If you have a question, specific questions, you can post it in the Q&A rather than in the chat, right? Because then it's easier for me to track the questions, right? All right. So nowadays, actually, I don't do a lot of kind of the presentation deck, but I try to show the how it works, right? So today I try to squeeze as much as possible, but let's see how much we can squeeze within 1 hour, right? So the agenda is, first I'm going to talk a little bit about this calculation mode in Aspen Flash system analyzers. I think that's the core part, and I will do some demos around that, right? Merging model is important, and maybe export import, especially the integration with process simulations. I will try to cover that, right? Okay, right. So I will use this slide as my guidance in terms of the content I need to cover, right? So let me bring up the other window, right? Okay, so if you open Flash System Analyzer, this is the Flash System Analyzer version 14, right? And I haven't started any cases, right? So I will first open one of the example case, right? Give me 1 sec. Yeah, it's opening the window. It's loading. All right, while it's loading, right? What actually Flash System Analyzer? Flash System Analyzer is a high calculation hydraulic tools for either sizing or checking or rating a flare header, right? So typically a flare header is it start with this, right? It start with the source, and the source we can put it, in Flash System Analyzer there are two category of source. One is the PSV, right? One is the symbol is control valve. So it can be really control valve, it can be a blowdown valve, right? So these are the two types of the source in the Flash System Analyzer. So we model the source, which is basically the conditions of relief, how much is the flow rate. Then we model all the pipe downstream of the source, all the way till the releasing point, right? The releasing point typically is the flare tip, where it could be flare, it could be fan, right? It doesn't matter because we're calculating the hydraulic, right? So why we use why we don't use maybe other tools like HYSYS pipe segment, etc. I think because one is the criteria. First, maybe it's a network. First, maybe I would say it's a network, right? There's a lot of pipe joining together to the headers, and you can actually have multiple tip, right? So it can be a complex network, right? So this one, the one I show you, a simple network, which is what we call convergence network, because it's converging into a single flare tip, right? If you have two flare tip, then you can say kind of divergent, right? So there are also headers which has interconnecting piping, which create loops, etc., right? And basically when we do, it's not like typical piping, right, where we calculate the calculation forward, right? We calculate. Okay, so the sample example is in the installation. So I don't really use any customized file, right, Hassan? Then sorry, I was yeah. So it's not like calculations of a typical pipe where we actually maybe start with the inlet pressure, and we put the geometry, etc., and we calculate how much is the outlet pressure, right? In the flares network, actually, the calculations is backward, and there's a term of back pressure, right? So we want to know at the release point is actually atmospheric, right? At the tip, outside the tip here is atmosphere, right? Atmosphere, right? But along this, right, is actually there'll be a pressure gradient, right? Uh, According to whatever flow at that point, right? Then the it will this is the pressure gradient, right, from atmospheric all the way till the flange. Just let's say the flange of the outlet device. It could be the flange at the PSV. It could be the flange of the blowdown valve, right? And this what we call back pressure, which is the pressure acting on the downstream, right? This is for relief. It's important because, like for example, PSV, right? PSV we have different. Sorry, I'm just talking. Okay, PSV has a different types, right? So we have PSV for type conventional, which can only allow about maximum 10% of the set pressure, right? Then we have a balance below, maybe can be go up to 50% of the set pressure, and we have pilot, right? So because the back pressure, right, is actually it will impact the how much flow can pass through the PSC for a given size, right? Especially for uh, I guess typically what we say non critical, where the back pressure is already high enough, right? So that's why it's important, right? And typically this become a criteria for checking the sizing, right? The sizing of the pipe, right? Other criteria, other typical criteria for sizing the flare network is typically also so back pressure is one, velocity, right? The velocity is typically stated in Mach number, right? Is as a ratio to the sonic velocity, right? The other one I think is momentum, right? So because when it release, right, it can actually cause vibrations to the pipes, etc. Right. So this is but typically company put some criteria on the momentum, right, to allow to when designing the flare network, right? Okay, so that's kind of the background why we need flare system analyzer, right? So we want to be able to check our flare header, and flare header typically also is it can be one single flare header depending on the facility, depending on the operating or the design conditions of the equipment in the plant. Some plants they do have segregations like HP flare header, LP flare header, or even medium flare header, right? So each will have allowed maximum design pressure release to that header, right? Okay. All right. So okay. So I want to talk about first. I like to start first with the calculation mode, right? So you can see here, right? There are three calculation mode, right? First is the design. So design is actually the goal is we put the the configurations of the pipe like this. We put the length, right? But the size is to be calculated. Of course, flare system analyzer by default, when you add a pipe, I will show you when you add a pipe, by default, it will always give a size, like say 12-inch, right? But this size in design mode, right? In design mode will be calculated. will be calculated. It's calculated based on what? Is based on the criteria we mentioned, right? So design is basically, it will calculate and give you the size of the pipes, right? So that's design mode based on the criteria you specified, right? And scenario and criteria. Scenario determines, later I will talk about scenario, right? What about rating, right? Rating mode is basically you specify the size, the length, etc., right? And it will check against the criteria, but it will not change. It will highlight in, let's say, red if the any of the criteria is exceeded, right? Okay. The third mode is called debottlenecking. So debottlenecking, it could be if you use, could be you have a flare network and you might install a new system, a new skid, etc., right? So you have maybe multiple 2 or 3 relief device forming a subheader and joining to the, let's say like this, joining to the main header, right? Of course, you only want to size the new system which is added. For example, maybe this part, right? So we can identify that using debottlenecking, and we can say this pipe is to be sized, but the rest cannot be changed, right? So it's a mix between rating and the design, right? So okay, so that's kind of the brief, all the 3 calculation mode, right? So let me go into design, right? So I will just quickly let me close this and start with an empty right, empty file. All right, so this is just a label. Can just click OK. Right, so you see the first thing it will ask what is the composition, right? So the composition, let's say I'm just going to put this, right, and click OK, right? Right, and it gives you an empty sheet, right? And the first thing typically what we do is we put the sources, right? So let's say the sources, it could be a PSV, it could be a blowdown valve, right? Then we start putting the pipe, right? How this pipe joins forming from the tailpipe, right? So we there is a terms, especially for PSV, right? There's a tailpipe. Why? Tailpipe is the pipe immediately after the relief device, right? Before it joins to form before joining a subheader or a header, right? So why we differentiate between tailpipe and, let's say, non-tailpipe, right? So tailpipe, because when we say tailpipe, right, is that pipe is only dedicated for one relief device, right? Is only for one relief device. Is typically the term is used for the PSV, right? So there's no other relief device meant to join there, right? That's called tailpipe. So if you see, right, when you read the standard or whatever company design guideline, tailpipe actually allow higher or let's put it less conservative criteria. For example, in tailpipe, maybe people will allow 0.7, 0.8 Mach number velocity, right? Compared to when you're designing a header header typically maybe 0.5, 0.6, right? And could be maximum 0.7, especially for greenfield, right? Because what? Tailpipe is only meant for one relief device. There's and you don't foresee that you will tie in another relief device to the tailpipe, right? So you can actually try to squeeze more. So that's why the criteria typically is less. It will be like trying to maximize, right? Well, header, right? Especially the main header, right? You never know. There maybe in the next 5 years, etc., your company might add another system. Then it will have to tie in to the subheader, which ultimately release to the main header, right? And if that system has a simultaneous relief with other system, right, that will increase the load to the main header. So main headers should have more buffer or more ability to take maybe future load, right? So that's why, especially greenfield, you will size it maybe like 0.5 mark, right? Because it gives you a margin to add more capacity in the future, right? So I think that's I want to say about tailpipe, subheader, etc., right? So let me build this, right? So it should end with a tip, right? Of course, there's a KO drum. I guess I'm not putting it now, or maybe I'll just put it like that, right? So to build this, right, you can yeah, Omar, I plan to cover that at the end. Sorry, yeah. I'm feeling really under the weather, but yeah, you guys give me energy, right? All right. So typically, how I build, I hold down the control, then I just connect this, right? Right. Let me build this. All right. So this network, this is just a diagram, right? So what's missing, especially for the pipe, right? The pipe, of course, like I said, this here you have to tell which one is a tailpipe. So this one, yes, right. Oh yeah, the other thing, tailpipe has different criteria, right? I think different limit of the criteria. The other thing also in API typically they ask tailpipe needs to be sized for rated flow rate, right? It's not design flow rate. So PSV calculated load, let's say 1,000, but you have to size the tailpipe based on the rated flow rate. Like let's say for a selected orifice, the rated flow rate could be, let's say 1,200, right? So that's why it's important to identify which one is a tailpipe, which one is not. Right. Right. So you can see the connection. This pipe is tailpipe, right? Then under the specification, right? So you can see here the most important specification, of course, like the length and the elevation change, right? So this is I'm starting with a design case, right? So it is also where you are in the engineering phase, right? Sometimes in the beginning, as greenfield project or whatever, right? You don't have the details configurations of isometric where you can get exactly how many bands, how many lengths, etc. What are the valve involved, right? So probably you don't have the complete PNID, etc. Layout has not been built, pipe has not been routing, but you need to do this preliminary sizing, right? So typically you might put, in that case, right, you might put still a straight length, right? So maybe you draw based on the layout, you say, oh, this equipment is this is where my main header, and maybe this pipe is, let's say 50 meter, right? Remember, this is a straight length, right? K. I'm going to, so the important part is the length, right? So for pipe, right? So let me fill that, right? So I'm just going to put some length also here. Let's say this is 30 meter, right? Then this is, let's say, well, my computer a bit slow. Let's say this is another 50 meter, right? Then this is, let's say, 100 meter. All right. Okay. Okay, so the pipe is defined, right? So now we have to define other components, right? Before I define other components, right, I'll go to the source, right? So let's say this is the source, whatever here, right, is should be comes from your either blowdown calculations or PSV sizing, right? So it will ask you what is the relieving, right? Okay, what is the set pressure? Let's say this is set pressure, putting some numbers here, right? 15 bar, right? Relieving pressure. So this is, you see, this is the contingency. So we have two, either operating or fire. That is the PSV size, right? So I can, whether it's user specified or it's to be calculated, right? Relieving pressure. Okay, inlet temperature, let's say 50. Let me put this number first. I think there's something wrong, right? I will then override. There's something not right if I put, okay, 10 operating, which is 10% overpressure. It just this makes sense. Let me change it to 15. This should change. Funny. Funny, it doesn't change. Sometimes it does happen. Okay, let me just put it 10 first. Okay, inlet temperature, then allowable back pressure, right? Allowable back pressure will be based on the type of the valve, right? Let's say this is a pilot, right? So you can untick this, then it will, sorry, not pilot. I want to choose conventional actually. So this is about 10%, right? So it calculate, right? Outlet temperature, let's just put 25. Mass flow, let's put something, maybe 10,000, right? So the and this is, that's why this is has a rated flow, right? The rated flow, typically we prorate it from the size of the orifice, the calculated orifice and the actual orifice, right? So let's say for this case, right, I need to put the composition first. Give me 1 second. So and again, this is could be sorry, during the initial design, probably you don't have a lot of, or you don't want to put a lot of details. Maybe you just go by molecular weight. We can do composition, but depending. So let's say just assume that, okay, maybe at this case you have the molecular weight, right? So 24. This, it will just distribute to the relevant component to get 24 molecular weight, right? But you can change. If you have more information, you can put exactly the mole fraction or the mass fraction, right? Let me go back here. So then I want the rated flow to be calculated, right? So I can untick this. So you can see this rated flow is only 500. Our target is 10,000. That means this D orifice is not sufficient, right? So let's put L. It's getting there. It's actually more than already 13, right? So let me test it one more time. What about K? Is it K? Cannot, right? It's below the required flow rate. So I think, yeah, L seems to be right. Okay. So I think this is done for this input, right? So let me click OK, and then before I create anything, let me save this file. Right, where's my mouse? I can't see my mouse. Okay, here you go. Okay. Okay. So I've done the first relief valve, and this is the second source. It could be a control valve, it could be blow down valve, right? It is a simpler input typically, right? So let me just put here. It's okay, 10 bar. Let's say 25 is okay. I'm just going to put some. Right. This is maybe 5,000, right? Composition, maybe I'll put. Let's say 18. Right. Okay. Right, and now I think the other thing is this. It has a default diameter. Let's just take that. Right. So this one I have put that, and I think the flare tip also typically has the input of the opening, right? Diameter. So let's put, I don't know, maybe 500. 500, right? Maybe just one. Yeah, fine. I just put 500 first. Okay. Okay. All right. So, okay. So you can see here, this is we can change the calculation mode, right? So the calculation mode can be rating. In this case, I want to be design, right? Because I have not changed. If I go to the pipe, right? I've not changed. Sorry, the pipe input is here, right? I've not changed all the. You can see all the size is still default size 12 inch, right? And I want to size this, determine is this the right size or not, right? Okay. Then before that, right? So we talk about the length. I've inputted the length, right? But in reality, there's no like a straight pipe, right? There's always fittings. We have not take into account the valve, elbows, etc. So there's a concept of equivalent length, right? So if we don't know, we have to still maybe consider some additional length to cater for the elbow and the valve, etc. Right? We don't want that. We don't want to be caught later when we add the details. Then the size is not sufficient, right? So how we do that, right? We can go to the pipe, right? So that is basically, and maybe I will add this to all the pipes, right? I can select and click edit, right? That's, in this case, we can go to the fittings, right? So there is a length multiplier. This is something we can use to give some additional factors or additional length based on multiplying based on the, let's say your straight length you have calculated, right? So let's say we put 20% more, right? 1.2, right? So if I put it here, it will get applied to all the pipes, right? All right. So you can see, I will check. So you can see the length multiplier 1.2 is applied for everywhere, right? Okay. So the next thing is, you can see here default scenario, right? So we need to define like, for example, there are conditions or scenario. Typically, flare net is used for multiple release scenario, right? It could be a fire case, a failure of cooling water. You want to check, okay, if this happens, right? you might assume, okay, maybe this fire zone, all the PSV is assumed relieving, right? So you will need to make sure all this the source is active, right? So where you define that is under the scenario, right? So let's say you can have multiple scenario, you can clone and edit, right? Scenario is there are two parts, right? One, it determines the which source is active, right? So let's click edit. So you can see here which source is active, right? If you tick, it's actually ignore, right? So that means in this scenario, both source, because I don't tick, is active, means it will release at the same time, right? And the other thing about scenario, you can apply a different criteria, right? So for example, here you can see, let's say the header, like I said, I put 0.5, right? I'm putting only one criteria now, right? I don't put other criteria. Tailpipe 0.7, right? So I click OK, right? Then I think I have enough, right? So I will run the design case, right? So what it will do, it will iterate the changing the size, right? So it will give you warning because design will change the size. Is it? Okay, there's something. Okay, let me check whether the result is. Oh, maybe the flow rate is too small. It becomes, everything becomes 2 inch. Okay, let me do. Is it true? Hold on, huh? I think there's something. No, I don't think so. Let me check what's wrong. Calculation setting. This is default scenario. Okay, calculate. Okay, I need to check. Make sure it's calculating the scenario, right? Oh, still not calculating. Okay, let me check. This is unusual. Nominal diameter. Or let me put this size first. It doesn't running. Give me 1 second. Trace or error message. Calculation 36 error. Okay, let me check. What is the error? Flash value. think it's actually could be. Sorry, I didn't test the value, so I need to do some trial. Okay, sorry, Gerald. Yeah, let me do it. Oh yeah, thanks, Gerald. All right, okay, thank you so much. All right, so you can see, right, it's actually sizing. Of course, in this case, right, maybe we didn't limit the size. You can see here there's a 5-inch size, 3.5-inch size, 8-inch size, right? But the point is, it's actually iterating, right? It is iterates and change the size of the pipe from the original 12-inch to meet the criteria, right? Then we can take a look the report here. The report here, right? What is, for example, what is the noise? What is? But again, this is still a crude calculation, right? Because we haven't put other maybe details, a lot of details. We just put, let's say, a multiplier. We haven't considered, let's say, heat transfer if you want to check temperatures of the pipes, etc. Right? But this enough to get you the preliminary sizing, right? So this is the design mode, right? Okay. Okay, let me switch, right? So then typically also we can switch to rating mode, right? So once we have this preliminary, we can add more details, right? Or if you want to, if this is an existing flare header, you can also start with rating, right? So let me switch to rating, right? First, I will try to uh, I want to try to uh, show you how rating operates, right? So let's say this is has been sized for this flow, right? So I can either change the flow or I can change the pipe, right? So let's say the condition change, right? So this is, let's say, your existing pipe, right? But maybe your equipment change, you run a new relief load study and you're calculating the required relief, required relief, right? So let's say I'm going to update the required relief, right? So I want to check whether my existing pipe size still take, right? So let's say this become 7,500, right? Okay. So let's run, right? So because we know, right, it was sized for 5,000 for this 5-inch, right? Of course, when we increase, then it will highlight, right? So this is the functions of the rating, right? So it will check against the criteria and it will highlight which part of the network exceeding the criteria, right? So it highlight pipe 1 has some issue, right? But it will not fix, it will not change the pipe diameter, right? So you can go here and it will also highlight, okay, the back pressure is the issue, right? Because we have this is a conventional pipe, conventional valve. Then it the back pressure allowable is only 10% of the set pressure, right? While this is actually giving you more than that, right? So then you can manually change, right? So you can go to design, or you can also manually change and try, okay, let's see if that's the flow rate, then maybe I need to change my tailpipe, right? So I go to pipes, right? Then there's the size, right? Let me try to go to 6 inch, right? Then I run again. Right? It's still giving, right? So maybe I need to change to 8 inch. Of course, I can do this with uh, sizing, right? Or I can also do this by, maybe I demonstrate a little bit about. So I think you, you should understand about the rating, but let me switch it to debottlenecking, right? So the debottlenecking actually allows me to say which pipe I want to change, right? So we have to, there's a, every pipe, there's a, whether it's a sizable or not, right? So you can see whether this is sizable or not, right? So the bottleneck will look at which one is actually sizable, right? So let me put this back to 6 inch, right? We don't know whether 8 inch will meet, but I want to put this as no, the rest of the pipe as no, right? I want to see, let's say that is the only, somehow that equipment has a new conditions increasing the relief load, then I want to know, can I just change the tailpipe size? Is that something possible, right? So because it's a modification, right? So this one, so I will put the tailpipe is sizable, but the rest of that pipe is no, and that you can run in the debottleneck, right? So it will only do the design calculation for that thing and will keep the other pipe uh, uh, not changed, right? So let me put this. Let me put this. Let's say I put. I think 6 inch is no. We know is not, right. Let me put in the initial condition, right. 5 inch, or maybe it's okay. I'll just put 6 inch. Then I'll run this, right. Right. So let me check, right. So let's check. Okay. So it seems like uh, 6 inch is actually is fine. So you can see 6 inch is fine, right? Let me demonstrate by changing the pipe, right? So maybe I'll change to 4 inch. So that it is like, oh, sorry. So you can see, right? It was 6 inch and it changed to 8 inch. You see, this has become 8 inch. It was 6 inch when we first run, right? So this, the debottleneck, right, will look at which pipe is sizable, which I say only this tailpipe. Then it changed this to 8 inch, right? So this is the calculation mode for debottleneck, right? Then I want to go go back to rating mode, right? So rating mode, like I said, you can use this like after, it can be used like after you get your preliminary size from the design mode, then you switch it to rating mode, and this is where you start putting details, right? Maybe the details is basically you change the equivalent length. Last time we put equivalent length 1.2, and you can put it this, if you already know the configurations, you can change it this to 1, and you put exactly the what is the fitting. That's also one can, right? Then you may be enabling the heat transfer calculation, right? So I think because during the design, right, you don't want to give a lot of calculation, heavy calculation, because it's doing iteration calculations on the pipe, right? So then you, once it got the let's say the first guess of the size, right? We can switch to rating, add more details, add more calculations, then verify whether the size still stand, right? So like for example, the heat transfer, updating the fittings, and you might update, for example, like uh, the flare tip. This is so depending on what information you have. You might add curve of the from the flare tip, right? So the curve is typically you obtain this from the tip fenders. So that is like how much pressure drop for different flow rate, right? So it gives you like, okay, for zero or definitely zero, maybe for 500 or 5,000 is how much pressure drop, right? And that's typically a curve, right? So that is used to calculate the back pressure, right? Because varying flow rate will have a different pressure drop uh, at the tip, right? So let me go to the if there's any questions, let me go to the okay. Let me read some question here, right? So Gerald, can you explain a bit how the algorithm works? Pressure is backward calculation and the mass flow rate balance is forward, starting from the source. Correct, right? And for the tailpipe, when we declare the tailpipe, it will use the rated flow, right? How about the energy balance? How it uh, iterates. I experience trouble most of the time when enabling the kinetic energy, so it will be helpful for me to know how flash system analyzer iterates the data, right? Okay, let me get back to you on this, right? So let me dig up and get back to you on this, Gerald. Uh, Omar, can you share a bit how to transfer PSV informations to HYSYS? Okay, I will do that after reading these questions, right? Sridhar, Aspen Flare System Analyzer, how is it different with FlareNet? Actually, FlareNet is the old name of Aspen Flare System Analyzer, right? This is actually the same. Right? Yofi, if we click the T, fitting editors calculation will find fitting loss method. Which method the best way for common for industry, right? So let me see. You mean this one, right? I think let me go and press F1. Yeah, sometimes I also read what method, then I just press F1. Sorry, my F1 is, I can go here. Reading the function F1. Oops, it's locking to projection. Okay, let me get back to you, Vijay also. Sorry, Yofi. I have I have a question. I've modeled PSV with rated flow rate where experienced to tailpipe outlet having MAC number 1, right? So MAC number 1 is meaning that is very much choke, right? The tailpipe inlet is not very high, around zero point 0.3, right? Uh, so it's like this, right? I think the tailpipe inlet is not very high, around the length is specified is very short, around point. Okay, I think that's interesting. You're saying that the 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 inlet is only like zero point 0.3, then it suddenly goes to uh, 1 mark, right? Uh, it could be, uh, yeah, I can't be sure, but it could be either. I mean, does seems odd, right? It does seems odd. It could be maybe the program error, but I cannot be sure, and maybe we need to see the file, right? Uh, I also experienced negative back pressure at the tailpipe during this time. All right. Hmm. It shouldn't happen, right? Yeah, we can. Let me see what could cause negative. So the only thing which I've seen when you have a negative, right, it's a like a negative flow in the network. That means it's actually, it could be because of the loop, then you have a reverse flow, right? I've not seen negative back pressure, right? Okay, all right, so I owe that one, yeah. uh, in the how does flash system analyzer integrate with other Aspen Tech tools, right? So this Aspen Flash as system analyzer integrates with HYSYS and Aspen Plus, because HYSYS and Aspen Plus has PSV sizing calculations, right? So let me find example, then we transfer the data, right? So that's the only integrations Aspen Flash system analyzer have, right? Yeah, Gerard, thank you for that trip just now tips. Ali, it was what Gerald said. I turned off the kinetic, right? And I think I need to also research about that kinetic calculations. Okay, more Tesa, the drum and the flare tip setting. So this one is actually for the flare drum is essentially it's just a diameter, right? How much is the diameter of the drum, right? For the flat tip, it's the size of the orifice of the tip, right? So this is the dimensions. Typically, is quite small, right? And the other thing, you can also improve the calculation here by doing a curve, by inputting a curve, right? You can enable this curve and input the curve you get from, let's say, Fender. Let me mute. I'm going to. Okay. Okay, I hope that answer. Okay, right. So let me do one thing. The other thing is, let me open HYSYS, right? I will demonstrate importing a data from the flash system analyzer, from HYSYS data from to the flash system analyzer. Right? Sec. Yeah, I think I might be running few more program unnecessarily. It's a little bit slow or slower. Could be. Okay. My size. Hard disk. Okay. This is a virtual machine, so yeah. All right. Okay, maybe I'll do one thing. I will send a recording which shows you the. Yes, is it opening? How to import data from HYSYS to file system analyzers. If I can, this is already open. If I can just do it quick. So let's say relief, right? We have relief, pressure relief. Maybe this way. Okay. Okay, let's see how many PSV, what PSV we have here. Safety analysis. Okay, we have this PSV. Okay, let's say this. Or this is a. Okay, we have few PSV, right? So let me check. Let me check this PSV 100,001. It's actually scanner. I want to see the. Okay, the scenario. Let's say this is block outlet, right? I can click this and open scenario. It's actually I can see here also. This is the flow rate 5.35 something, right? The condition they don't see. I think I need to open the scenario, then I will see the condition. This is the conditions 104 degree F, etc. Flow rate 5.35 exponent 4 pound per hour. Okay, let's try to import this data P100 PSV01, right? So this file, let me make sure. So the file is here, pressure relief benchmark, right? Go back here. you can go here, file, import sources, right? So import sources, we can import stream blowdown calculation from HYSYS or PSV, right? So this is a PSV, can be a Aspen Plus or HYSYS. So we click, so we need to point to the file, right? I say that's the file. Open the file, upload the file, right? It will read the file. Okay, so you can see here, right? PSV, it reads all the PSV here, right? 100 PSV 001. So I'm going to transfer only one, right? So 100 PSV 001. First of all, it will ask actually, where are you going to transfer to which scenario, right? So because one relief source, right, it can have multiple scenario. You can have a block discharge case, you can have a fire case. So you need to map to the relevant scenario, right? If you're saying fire case for zone 1, that means we transfer the PSV data for that PSV on the fire case from the zone 1 PSV, the fire case, right? So let's say this is, I want to transfer this to, we have to identify which one, right? So we only have, because this is PSV, we only have one PSV. So this is the relief of one, right? Then it will ask you, because this PSV has multiple scenario, right? So let me, right, we want to transfer the block discharge, right? Block outlet, right? So you can see these are the numbers which going to be transferred, right? So we can click OK, right? Yeah, I don't need to save. You can save, right? So we can, again, then we can double click this to check the data imported, right? So you can see this is the updated, right? So this is 5.3 E4 pound per hours, right? This is updated, the flow rate. Let me check. I think the composition should be also updated. Right, it becomes, this is the compositions, right? It wasn't, we didn't, we were we specified, right? Just now we specify, I think, until butane, and you can see once we import, right, it actually reads the composition component list from HYSYS, and it adds the component list here also, right? So this is how you transfer. So you can transfer from PSV, you can transfer from blowdown, right? So I will create the recording to for this also. I will send via email or post it, right? So I think that's about it for today. I think we run a little bit over, right? But I think there's a lot more about the flash system analyzers, right? I will try to answer the some questions offline, right? All right. Thank you so much for your time. Let me stop sharing. Right. How do I stop sharing? All right. But anyway, yeah. Thank you so much, and see you again next time. I think next week. Oh no, not next week. I think the following week I have a plan for webinar also. All right. Thank you. Bye bye. Have a good morning, afternoon, evening.